Assalamualaikum. Today I want to talk about application of differentiation. So first of all is we must know the definition of differentiation. Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to another variable. Then the next definition is the derivative of a function of a number of denoted by f prime x is, as an example, dy over dx equal to limit h equal to 0, f in bracket x plus h minus fx over h. Then the objective of differentiation is to find the equation of tangents and normal to any curve at any point. Then the second objective is finding of rate of change of quantities. The above one is a rate of velocity. You can find rate of change of water level in a tank or rate of change of volume of a gas in an expansion or anything. So that is the definition of differentiation and objective of differentiation that we must know if we want to apply the application of differentiation.
Mom, the new tank behind our house is quite bigger than before. How much do you pay for the whole tank?
I'm not sure, Sarah. Dad paid for it. But what I know is it costs RM1.20 per square meter for site area and RM2 per square meter for base area.
Oh, I see. As it is huge, I think it can hold more water compared to the old tank before.
Yes, it can hold 60 meter cube of water as it is an open rectangular tank with square base. I think it may cost 288 over x plus 2x square for the whole tank. But I'm not sure. You can figure it out if you want, Sarah.
Alright, thank you, Mom. Hi Natasha, my house just installed new open rectangular tank with square base that can hold 60 meter cube of water. My mother said that it may cost 288 over x plus 2x squared for the whole tank. Can you prove that it is true?
Give the situation an open rectangular tank that has square base that can hold 60 cubic meter. Let's say x is the size of the base and h is the height of the tank. First of all, volume of the tank is 60 cubic meter. Volume of the tank we can get by using the formula x squared times h. So x squared times h is equal to 60 and h is equal to 60 divided by x squared. Next, let the total area of the tank be A. Since it is an open rectangular tank, A is equal to 4xh plus x squared. Total of the cost, C, is equal to 4xh times 1.2 plus x squared times 2. We times 4xh with 1.2 because RM1.20 is a cost for the sites, and we times x squared with 2 because RM2 is a cost for the base. Later, we can express C in terms of the x with C equal to 4x times 60 over x squared times 2 plus 2x squared. We solve it, then we get 288 over x plus 2x squared.
Tasha, can you calculate for me the minimum cost for the tank? Or maybe you can tell me the values of x and h that will minimize the cost of the whole tank so that I can calculate it by myself. Hehe.
Yes, sure. For this problem, we can start with differentiate C in terms of x. So we differentiate 288 over x plus 2x square and we get negative 288 over x square plus 4x. Next, we must find the critical value. The first step is we make equation dc over dx equal to 0. The second step is we substitute dc over dx with negative 288 over x square plus 4x. The last step is we solve the equation and we get x equal to 4.16. Next, we must test the critical value by using the second derivative test. So we make equation d2c over dx squared equal to 0. We differentiate dc over dx and we get 576 over x cubed plus 4. Then we substitute 4.16 into 576 over x cubed plus 4. When x equal to 4.16, d2c over dx squared bigger than 0. So c is the minimum value. When x equal to 4.16, h equal to 3.47. By substitute x value in equation, h equal to 60 over x square. Do you understand?
Yes, I understand. Thank you, Tasha.
Hi Sarah! I saw the tank behind your house yesterday. It is really huge. How much is the cost it is?
Oh, hi Nani. Yeah, we just installed it a few days ago. After I made calculation, the minimum cost maybe 103 ringgit 90 cent. But later I asked my dad for the exact cost, okay?
Oh, okay. It is affordable. I'll ask my dad to install it too later.
Yes, you should, as it can hold to 60 meter cube of water, and it is more than enough to support us when there is water crisis.
Yeah. You're right. Okay, Sarah. Thank you for the information.
You are welcome. See you.
Now we can see Sarah's curiosity for price of the water bills for her new tank solved. By using applied maximum and minimum value, Sarah knows the lowest and the highest price for her water bills. In the nutshell, maximum and minimum value can be applied in our daily life. That can be found anywhere when we want to find the highest and the lowest of our problems. That's all from me.